Hey everybody, these are the notes for up and over for the problems that are projectiles literally flying up at an angle and down. So first we're going to tweak the formula. So I'm going to start on the back, kind of like I did the last ones. All right, so we have AY equals VFY minus VIY over T. We have AX equals VFX minus VIX over T. We have dy equals VIYT plus 1/2 AYT squared. And dx equals VIXT plus 1/2 AT squared. Same formulas, all I just put x's and y's. So I'm going to start similar to the last time. There is no acceleration in the x direction. Projectiles go up in the air. The only thing that can work on them is gravity. And there's no gravity in the x direction. So in these problems, we have symmetry. So I should draw a little trajectory path. When it goes up, we have VI and we have VF. One is the same as the other. So if this is positive, that's just negative. On the upside, I have VIY and VIX. Remember, horizontally, as it comes over here, VIX never changes. It just goes forward. VFY is now down, but it's the same value. So if this is 10, that's negative 10. If this is 20, that's negative 20. So VFY is the same as negative VIY. So I'm going to substitute in here negative VIY. Well, now I have negative VIY minus VIY, that's negative 2. Negative 2 VIY over T, and gravity is negative 9.8. So we're going to simplify even further. Negatives are going to cancel. I'm going to divide both sides by 2, and I end up with 4.9 equals VIY over T. That is my simplified formula. In the horizontal or the distance formula, again, I have no acceleration in the x direction, so it simplifies to this. dy equals VIY. VIY will exist in these. There's not zero. And the only thing we're going to simplify is this. It's just going to be equals VIYT minus 4.9 t squared, because half of gravity is 9.8. All right, so let me put these on the front. I want you to do this as well. So dy equals VIYT minus 4.9 t squared. dx equals VIXT, and let me make sure I don't copy the one. Yeah, 4.9 equals VIY over T. So these are our tweaked formulas for up and over. All right, so we're going to do a little, here's the ground. Here's my trajectory. A toy rocket is fired at 55 degrees above the ground, and its initial velocity is 40. So here's VI is 40 meters per second. That's going to go, we can do some symmetry and come all the way down to the bottom. VF is simply going to be negative 40 meters per second, and the angle will still be 55 degrees. It's not negative, it's just with the ground. So in my picture, this would be 55 degrees as well. And this is my VF. So I'm going to do a little blow up of the beginning of this to get the VIX and VIY, because it is like a little triangle. So I'm going to blow this part up. Here's my VI of 40. And then I have VIY, VIX. And here's my 55 degrees. Well, you can see I've made a triangle. And it's my favorite triangle, Lieutenant Dan. I'm missing the legs. So in the same way we did before, we're going to use cosine here, we're going to use sine here, and they're going to be times. So VIX, so here's where the notes are. VIX is going to be VI times cosine theta. VIY is simply VI times sine theta. To get those components. Try to get a little more light on this calculator this time. All right, let's go. Clear. So I'm going to take 40 times cosine 55. That gives me 22.94 meters per second. All right, 40 times sine 55. Oops, 40, I keep hitting divide, sorry. Sine 55, there we go, 32.77. All right, because of the symmetry, I'm going to go down to the finals. VFX doesn't change, so it's going to be 22.94 meters per second. Same as VIX. VFY is going to be negative 32.77 meters per second. Again, it's the same as VIY, but negative, that's an N. So our chart's filling in pretty quickly here. It's a little different than the Cliff problems. All right, so now what do we do to figure all this out? We're going to start with time. We're going to use that 4.9 equals VIY over T. All right, so 4.9 equals, and this is where we want to make sure we don't mess them up, it's 32.77 over T. Now remember, solving in the denominator, these two flip. So on my calculator, I'm going to have 32.77 divided by 4.9. I'm going to get 6.69 seconds. Now, T1/2 just stands for the halftime. So I'm just going to divide this by 2. I'm going to use 3.34. And this is used only, you can find the height anywhere, but this is used only for finding maximum dy, the maximum height of a trajectory. And now we're just going to use the two formulas. They do take a little bit, so let's put down here. So we're going to use the dy VIYT, and remember we simplified it to 4.9 t squared, and the dx is going to be VIX t. And so we want to make sure in this one we're going to use halftime for both of those because I want to find the maximum height. All right, so let's do this. 32.77 times, this time 3.34 minus 4.9, 3.34 squared. The dx, let's see, VIX is 22.94, and this is whole time, so we're going to use 6.69. All right, so let's figure those out. I'm going to do the second one first. 22.94 times 6.69, 153.47 meters. I'm going to do the next one in stages. I'm going to do 32.77 times 3.34. It's 109.45 minus, all right, so I have 3.34 squared times 4.9, 54.66. And you're generally going to find that this number minus this number is going to be almost exactly that number. All right, so clear 109.45 minus 55.66, 53.79. So almost 54. All right, the very last variable is simply this VY1/2. That is, what is the vertical? Remember, anytime it's Y, we're talking vertical velocity halfway. Well, as something goes up and it gets to the very top, it only has horizontal velocity. Okay, so at the top, the vertical velocity is 0 meters per second, and that will always be 0. All right, that is it. Thanks for watching.